This is a major servicing of a 7.5-ton rooftop unit with a single stage of natural gas heating and economized with 2 stages of mechanical cooling. We do a quick inspection for odd vibrations or noises, which can help us identify an obvious issue. We begin by shutting the power off to the unit. We remove the screws that keep the panels secured in place. Now we have access to the electrical connections, the 2 compressors that provide mechanical cooling, the supply fan, the heating section, and we can see the inside of the condenser coil as well as the condenser fan. On the side of the unit we have access to the Economizer section, the air filters, the Evaporator coil, and also the Condensate pan. We remove the filters and check for their level of dirtiness. If they're clean, the filters should be changed less often. If they're very dirty, they should be changed more often. We inspect the evaporator coil for any refrigerant leaks or obstructions. It's hard to see here because of the lighting, but we inspect the condensate pan to make sure there's nothing that can restrict flow and cause an interior leak, and make sure there's no mold or mildew present, which is a health hazard. We make sure to align the filters per manufacturer directions, and replace the filters so there are no gaps which will allow air to bypass. We inspect the condenser coil for refrigerant leaks, dents, bent fins, or obstructions such as cotton willow. If the coil is dirty, then we recommend the coil be washed. Now we turn the power back on to the unit so we can test its operation. Some units have a built-in test sequence where the economizer is the first stage of cooling. On other units, the economizer function must be triggered from the economizer control unit. We verify the dampers open and close all the way and any linkages are tight and aligned. Next, we trigger the first compressor used for mechanical cooling into operation. We can verify the refrigerant circuit is correctly charged by using gauges, or as you can see here, by measuring the temperature of refrigerant entering and leaving the compressor. We prefer to check the temperatures as every time the gauges are hooked up and removed, a small amount of refrigerant is lost to the environment. This is a 3-phase compressor, so we check the amp draw on each of the different phase legs and verify it's operating inside of manufacturer's specification. We can also check the voltage being provided by each leg. We trigger the second compressor used for mechanical cooling into operation and do the same verifications as we did for the first. Our final cooling section verification is we measure the temperature of the air being supplied to the space. Next, we visually inspect the condenser fan for correct operation and make sure the amp draw is inside of the manufacturer's specification. We move on to the unit's heating operation and trigger the test mode to put it into heating. We make sure everything's operating correctly and use our hand to feel if the flame has ignited inside the heat exchanger. Once again, we measure the temperature of the air being supplied to the space, making sure the unit is warming the air properly. Next, we move on to the supply air fan. We verify the motor is spinning and there's no odd noises or vibrations. And make sure the amp draw for the fan is inside of manufacturer's specification. We need to make sure the fan stays off, so we shut off the power feed to the unit. We check the drive belt condition and that its tension will not allow slippage. We use our finger to feel inside the pulley and shift for wear, recommending that it be changed if the grooves are too deep. If scheduled or necessary, we change the drive belt. This should be done at least once a year due to the belt stretching and wearing from use. We do a final inspection of all the unit's refrigeration components and pipes for any leaks. And also inspect for water inside any compartment, which would indicate an overflow or shell leak. And we make sure electrical connections are secure and for excessive wear on contactors and switches. Finally, we replace all the panels on the unit. Then clear any debris from the condensate trap. We turn the power feed to the unit on and do a final verification that the unit is operating correctly. We are finished with the major servicing of the 7.5-ton rooftop unit that has a single stage of natural gas heating, an economizer, and 2 stages of mechanical cooling.